Very good morning, my dear friends. I heartily welcome you all to my YouTube channel. And friends, in today's video, we are going to work out a problem on the solid shaft. Friends, the question for today's session reads like this: a commercial steel shaft, 1 meter long, supported in a square bearing. A pulley of diameter 500 millimeter weighing 600 Newton is mounted at the free end of the shaft and receives 25 kilowatts at 1000 rpm from an electric motor mounted exactly below it by a flat belt drive. Taking the coefficient of friction 0.3, the angle of lap 180, determine the diameter of the solid shaft required and what is the bearing pressure at the bearing. Friends, here in this question, first of all, we have to see what are the loads coming on the shaft. So it's a clear indication that the shaft is transmitting power at some RPM. This indicates there is MTE in the shaft or the torque in the shaft. And then there is a pulley of some dimensions given. So friends, remember, whenever any of the shaft carries external elements such as a pulley, a gear, or a flywheel, etc., the shaft is subjected to bending. So the moment you see a gear, a pulley, or gears or pulleys on the shaft, it's a clear indication there is bending moment induced in the shaft. Friends, from this data, we can finally conclude that the shaft is subjected to combined bending and torsion. And we need to find out in the first part what's the diameter of the shaft required. So we have to find out what is D, the diameter of the solid shaft required to transmit this amount of torque and the bending moment. Friends, we have the expression for the solid shaft given by the equation capital D, the diameter of the solid shaft is 16 over pi into tau d. Then we have got kbmb whole square plus ktmt whole square to the power half, and the complete quantity on the right hand side is raised to the power 1 by 3. This is the equation to find out the solid shaft diameter. Then what are these quantities? So let us start from this tau Vd. Tau Vd is the permissible shear stress. And it says in the question that it is commercial steel shaft. Friends, for commercial steel shaft, as per ASME code, the value of shear stress tau Vd is equal to 40 Newton per mm square. This is the value of tau Vd. This is very important. You need to remember this. And what are these Kb and Kt? Friends, assuming steady load condition, Kb is 1.5 and the value of Kt is equal to 1. Then comes how to find out this Mt and Mb. Friends, whenever you have the power and the RPM, you can say the torque transmitted Mt is equal to 9550 into kilowatt power transmitted by N into 10 to the power of 3. Friends, here this is 9550 into power transmitted is 25 kilowatts divided by RPM is 1000 multiplied by 10 to the power of 3. And if you simplify, friends, this works out to 238750. 238750 Newton millimeter is the value of this torque. So friends, we know MT. Finally, we are left with finding out this MB. The calculation of this MB generally takes more time on problems wherein the shaft supports pulleys or gears, whatever it may be. So friend, let's see how to find out the bending moment induced in the shaft based on the loads coming on this. Friends, by reading this question, you can understand that there is a bearing or a shaft is supported in a bearing, and this is the notation we generally use for a bearing. And here, this is supporting a shaft of diameter d, which we are interested to find out. And at the free end of this, there is a pulley. So in the end, it looks like a circle. This is the pulley, and they have given you what is the diameter. This diameter is 500 mm, and it is weighing 600 Newton. The weight of the pulley will act downward. So friends, the length of this from the center of the bearing to this is given to be what is the length of this bearing is subordinate by 1 meter long. They have given you clearly. This is 1000 mm is the length of this shaft which is supported in this bearing. This is the pulley. Now friends, we have to see what are the loads coming on this. The shaft of diameter d supported the bearing here at the left end is carrying this pulley, and this pulley is receiving this amount of power by means of a flat belt drive. Flat belt drive. That means there is a belt connected to a motor here, and therefore the total downward pull on the pulley or on the shaft will be the tension T1 and T2, the tensions, the high tension, the slack tension, and plus weight of the pulley. So these are the three loads that are pulling the pulley of the shaft in the downward direction. So friends, if you are able to find out T1 and T2, the belt tensions, and since we know the value of WP, the weight of the pulley, which is given to be 600 Newton, friends, you will be able to find out what is the total load at this point. And once you know the total load, if you multiply this total vertical load by the length of this, you will be able to get what is bending moment. It's something like a cantilever fixed at one end and carrying a load at the other end. So the value of bending moment would be just the total vertical load multiplied by the length. So we have to find out what is T1 and T2. So friends, let's see. To find T1 and T2, the belt tensions. To find T1 comma T2. Friends, we got two unknowns, T1 and T2. So very obviously you need two equations to solve for this. One equation is, friends, the ratio of belt tensions is given by T1 by T2 is equal to e to the power of mu theta. So mu is 0.3, theta is 180 degrees multiplied by pi by 180. This pi by 180 is to convert that to radians. Friends, you get this ratio. So you'll be able to find out what is T1 by T2. So we call this as equation number 1. Similarly, friends, we have to get one more equation to solve for T1 and T2. Friends, if you have a pulley like this and it is having a radius R, this load into R, F into R will give you MT. MT is the product of the tangential load F into radius. So MT we know This tangential force is the difference between the tension T1 and T2, and radius is diameter by 2. Friends, we know the diameter, we know the torque, so you will be able to get what is T1 minus T2 equal to. So we will call this as equation number 2. So we know the ratio T1 by T2, we know T1 minus T2. By solving this 1 and 2, we will be able to calculate what are T1 and T2. So friends, once you have the value of this T1 and T2, as I said before, we can write down here total vertical load at pulley or at free end of the shaft is equal to T1 plus T2 plus WP, where WP is the weight of the pulley. So this is T1 we have calculated, we know T2, weight of the pulley is given to be 600 Newton in the question. So you will be able to get what is the total vertical load. Friends, the vertical bending moment, or you can say the bending moment, is equal to total vertical load multiplied by L, the length. Friends, if you simplify this works out to mg value will work out to 28730 Newton millimeter. Friends, we have calculated MT, you have MB, and by substituting in the formula of this diameter D, we will be able to calculate the diameter of the solid shaft required. Therefore, we will substitute. So D is equal to 16 over 5 into WD, that is 40. Then you have KBMB whole square. KB is 1.5, MB is 287302 square. KBMB square plus KTMT square. KT is 1, MT value 238750 whole square, and whole quantity raised to power 1 by 3. Friends, this value of D, the diameter of the solid shaft, works out to 81.91 millimeters. So we can adopt standard size, adopt capital D is equal to, after this 81.91, I told you in one of the previous sessions, after 60 millimeter, there will be rise of 10 mm. So this can be rounded off to 90 millimeter. It is a standard size of the shaft. Friends, we are able to find out the diameter of the shaft required. And in the second part of the question, is asking us to find out the bearing pressure at the bearing. So we have to find out what is the bearing pressure. So bearing pressure can be found out using the formula. So the second part, bearing pressure is bearing load. Bearing load is nothing but the total vertical load at the bearing divided by projected area of bearing. Projected area of bearing. So we will represent this bearing pressure as PB, P suffix B is equal to bearing load. What is bearing load? That is the total vertical load acting. That is nothing but T1 plus T2 plus WP divided by the projected area of the bearing. So bearing is a square bearing. It will have L and D. We know the value of D. Since it is a square bearing, L is equal to D. So I'll write down this as L into D. where L is equal to D for a square bearing. So with this substitution, friends, you can see here, we have calculated T1, the tension on the tight side, T2, the slack side tension, weight of the pulley is known to us, the diameter of the shaft we have found out, L is equal to D, this is also D. So using this formula, we will be able to find out what is PB, the bearing pressure at the bearing, and this works out to 0.3977 and 3977 Newton per mm square. Friends, I hope you are happy with the presentation made by me. Please share this information with all your friends. Thank you, friends.